Welcome to this episode. Today, we're diving into the cardiac cycle, the fundamental mechanical sequence that drives each heartbeat. It's a fascinating process involving the coordinated contraction and relaxation of the heart chambers, and it's essential for efficient blood flow.
Yeah, it's really the heart's rhythm in action, right? The cycle includes both atrial and ventricular activity, and understanding how the valves operate is key to grasping how blood moves through the heart without backflow or mixing.
Exactly, and just to set the stage, this cycle repeats roughly 60 to 100 times per minute at rest, which is pretty remarkable when you think about the precision involved.
Absolutely. So let's start by breaking down the phases systole and diastole. Systole is the contraction phase, and diastole is relaxation. But what's interesting is that these phases don't happen simultaneously in the atria and ventricles.
Right. The cycle actually begins with both atria and ventricles in diastole, meaning they're relaxed and filling with blood. During this phase, the atrioventricular valves, the tricuspid on the right and the mitral on the left, are open, allowing blood to flow passively from the atria into the ventricles.
Meanwhile, the semilunar valves, the pulmonary valve on the right and the aortic valve on the left, are closed at this point. This prevents blood from flowing backward from the arteries into the ventricles.
That valve timing is crucial. Think of the AV valves as entrance doors that open wide when the ventricles relax, letting blood in and then slam shut as the ventricles contract. The semilunar valves, on the other hand, act like exit gates that only open when the ventricles push blood out.
Yeah, that analogy really helps, and during atrial systole, the atria contract to push any remaining blood into the ventricles. This atrial kick is subtle but important because it ensures the ventricles are fully primed before they contract.
Exactly, and during this atrial contraction, the ventricles are still relaxed, so they can expand to accommodate the extra blood volume.
Then comes ventricular systole, where the ventricles contract. At this moment, the AV valves close to prevent blood from flowing back into the atria. Simultaneously, the semilunar valves open, allowing blood to be ejected. The right ventricle sends blood to the lungs via the pulmonary artery, and the left ventricle sends oxygenated blood out to the body through the aorta.
The coordination here is really impressive. The closure of the AV valves at the start of ventricular systole is essential to maintain unidirectional flow. If those valves didn't close properly, you'd get regurgitation, which compromises cardiac efficiency.
Right, and after ventricular systole, both atria and ventricles enter diastole again, relaxing to allow the heart chambers to refill with blood, and the cycle starts over.
It's worth noting that the timing between atrial and ventricular systole is staggered on purpose. Atrial contraction precedes ventricular contraction to maximize ventricular filling. This coordination optimizes stroke volume and cardiac output.
And while we're focusing on the mechanical aspects here, it's important to remember that this whole sequence is orchestrated by the heart's electrical conduction system, which ensures the timing is precise.
Definitely. Also, the valves open and close in response to pressure gradients. When pressure in one chamber exceeds another, the valves respond accordingly. This interplay between pressure and valve mechanics is fundamental to the cycle's efficiency.
And any disruption in valve function, like delayed closure or incompetence, can lead to issues like regurgitation or reduced stroke volume, which can have significant physiological consequences.
So to sum up, the cardiac cycle is a tightly coordinated sequence of atrial and ventricular systole and diastole, with valve mechanics playing a central role in directing blood flow and preventing backflow.
The atrial systole tops off the ventricles, and ventricular systole drives blood into the pulmonary and systemic circulation. This cycle repeats continuously, maintaining effective circulation and oxygen delivery.
It's a beautifully orchestrated process, and understanding these nuances really deepens our appreciation of cardiac physiology.
Absolutely. Thanks for exploring this with me today.
Thanks. Until next time.